way the program is scheduled, we're about to start at 15:11. It's now 15:12, so we're already 1 minute late, and I really don't want to wait any longer because this is like a really exciting thing we're gonna do today. As you can see, I'm already surrounded. These are not my guests, but they could probably entertain you for a while just by themselves. Well, we're gonna see that. We're gonna dive into that with two amazing guests. One looks like, kind of a rock star. The other one like an action hero. But they are both on the forefront of robotics, and they both work here at the University of Twente. Here are Christoff Heunis and Edwin Dertien. Welcome, welcome. And decide for yourself who looks like what. You're already turning your machine on?
Yes.
Yours is already on?
It's also turned on.
And maybe we could just start with just a question. Who are you and what have you brought with you?
Yes, my name is Edwin Dertien. I'm assistant prof at the Twente University, working in the creative technology education track, interaction technology track. I'm also employed as a musician, as creative independent individual. So I'm also doing a lot of artwork for engineering. Might be able to show some examples later on of that bit. And this is one of my pet robots, a robot desk light.
A robot desk light. Who just?
Yeah, I thought.
Does it follow us? Does it react to us?
No. It just moves. It is just sitting there looking pretty until we get annoyed by it, and then I press a stop button. So that's it. It's got a mind on its own, so no stop button then.
Wow. Let's not stop it, but be careful that it doesn't tip our glasses. And you, I feel like this is kunst en kitsch, which is a reference you probably don't get, but
Nope.
Who are you and what did you bring with you?
Yeah, my name is Christoff. It's great to share the stage with you and Edwin. I'm working currently at the University of Twente as a postdoctoral researcher, and I'm also the co-founder of Flux Robotics, which is a robotic manufacturer company, and we manufacture medical devices for helping surgeons during their interventions. And behind me you see our first prototype, which we have developed in the past year with the R&D team, which also some members are in the crowd. And it functions as a robotic arm that moves an electromagnetic coil around the workspace. So if a clinician has a guide wire or the catheter inside the body of the patient, which also has a magnetic element, then we can use this magnet to move and position this guide wire as if the clinician can physically touch the instrument. However, they don't have to, since there's a small incision through which this instrument moves, and that makes it much more cost-effective, first of all, with regards to the duration of the intervention, and also much more safer for the patient.
Right, and we dive into that later in more detail. But first, tell me a little bit more about yourself. What's your background, and how do you end up here in Twente?
Now, I've always been an engineer. I also grew up in a family filled with engineers.
Did you?
And my dad was a mechanical engineer. He's also in the crowd today. And also have two brothers that studied engineering.
Really?
I want to say I didn't have a choice, but I really liked the option. And so I graduated as a mechatronics engineer, which is essentially taking the best of both worlds from mechanical and electric, and learning a little bit about everything. And then I moved on to biomedical engineering. I really liked how you can use technology to not only benefit industry, but also patients. So if you have an ailment or a disease, for example, if you have had a stroke and you need some help with rehabilitation, you can also use a robotic system to assist you with that. And so I really liked that combination of technology and the medical world. I really did also start to like academia, so I thought, okay, I want to explore both of these areas. And I came across University of Twente, which is, of course, the prestigious technical university in the Netherlands. And they also have a great biomechanical engineering department. And within this department is the surgical robotics lab. And the name just said it all to me. So surgical robotics, what is that? So I had to explore further. That assisted me with just making the decision, doing a PhD in 2017, where I focused on the development of these robots. And at the end, I just thought, well, I don't want to see the system after all the blood, sweat, and tears, literally, literally some blood working around these robots. I just didn't want to see it gather dust in the corner of the lab and leave it behind and say goodbye to that journey. So I really wanted to continue with that venture, and you know, the clinicians that looked at the system also told me, we want to see something like this in operating theater because we can benefit with the system. And upon hearing that, it sort of, you know, my decision was made. And so now we're trying to commercialize this prototype and also discuss with surgeons how we can design and improve it based on their needs. And so we ensure that we want to bring a solution that that answers a problem and not searches for one.
Cool. So you're now also an entrepreneur?
Yes, apparently so.
And switching to you, because I was surprised to learn that you both work in somewhat of the similar fields on the same university, but haven't met before this day.
No. Robotics is, of course, a very broad theme. So it's, as you already said, like the field of mechatronics. It combines the best from mechanical engineering and electrical engineering. So both the people from electrical engineering would like to pursue it, and the people from mechanical engineering would like to pursue it. So right. that's where you already have the two traditional faculties sort of enter in the same field. So I'm also in a robotics group, but the robotics group I'm involved in has a background in electrical engineering. I guess your group has the background in mechanical engineering, and of course, topic-wise, you get research interests that at some point converge. Yeah. Because indeed, medical robotics is how to say it? It's a booming thing. It's really an interesting point that can bring healthcare forward. So yes, also our group is working on similar topics. Fortunately, right now there's also at Twente University kind of motion to merge. Well, if not really merge, but at least to bring together all these expertises more into a sort of robotics consortium. So things are on the move. Right. But yes, as a field, it's traditionally really broad. It's a really broad scope. Yeah. So also with a different background, we also have a group, for instance, from information science. We're also doing a lot of robotics, but mainly from the programming point of view. Yeah, we also have a group of behavioral scientists also working on robots, but more from the experimental and human interaction kind of view. So yeah, it's a really broad field. It needs different approaches. And yes, that's what you get in academia, that sometimes these different approaches are sometimes becoming small islands somewhere in the whole organizational structure. So that's also the reason that while we're working on robots and even sometimes, well, apparently not very similar robots, but it's also moving, it's also about joints, it's about coordinate space, it's about inverse kinematics, it's about the same topics, but yeah, from a different point of view.
And they also now started in collaboration with the TechMed Center at the university, which is the technical medicine hub for students that want to learn more about the clinical aspects to become assistant nurses or surgeons themselves, right. But also to then integrate their knowledge of the technology behind it. And there's now a new initiative where they form now a robotics department, which I think should have happened already a long time ago, because that would probably have led to us meeting sooner. Yeah. Which I definitely support. This is where students will learn more about the applications for robots and not just how they function as manipulators.
Yeah, but there's just so much that you need to know and understand about robots before you can actually use them, because indeed the engineering, but also the electrical engineering, the software, the programming, but all the human aspects, it's just too broad to be covered by just a couple or just in one person, so to say, or just one research.
But you knew about a project Edwin was involved in, didn't you?
Yeah, the snake, robotic snake. Actually, I didn't even mention this before, but when I came here in 2017 as a wet behind the ear researcher, I sat in this introductory week with a few other PhDs that first week they started. And you were actually giving us a lecture, and you said, good evening, everyone. My name is Edwin. I'm an inventor. And I thought that's pretty cool, because you would say, okay, now you would try to, label yourself in that way, but eventually being an inventor enables you to understand, okay, there's a problem, how can I solve that? And that really sparked a lot of interest. But yeah, I just remembered that.
Can quickly show the project. I think we have it here.
Yeah,
on
because
the video.
that snake robot is.
Oh, that's you. That's me. Yeah, this is a snake robot.
Yeah.
Okay, quick show. Yeah, there we have it. This is real.
Inserted in the grid.
Oh, there's even sound with it too.
It's pressurized.
Okay. Okay. Now, quick question to the audience: what's wrong with this video? Yeah, I think we're in such a small group, you can also shout it out and I will repeat it. What's wrong with this video? Okay, I can sort of start it again. Okay. So, yeah, good. Let's stop at that. Oh, no. Let's stop at this image. Yes, this image. What's wrong? I think you spotted instantly. We never wear white lab coats. I mean, come on, we're engineers. I explained, we're electrical engineers, so that's messy stuff with wires and electronics and stuff. So this is also not our lab. You're missing a lot of coffee mugs and empty boxes and other rubbish and garbage, which is normally in a lab. So this is shot in a theater hall, especially to showcase this project to people like you, so you know. So always be critical when you see this like kind of glossy images. Which
And who thought of this to put you in the white lab coats?
I actually did it together with.
Okay.
Sorry. No, but
okay. At least now you're telling them.
Yeah. Okay. So now I tell this every time I play the video. I actually tell this. So that okay. this now it serves a purpose. But we might dive into this topic later on. There is a lot to be said about what we or how we as users, as viewers, as people say, how we observe robots and our expectations. I mean, this is right now doing nothing more than just looking pretty, but already, if you're not really careful, this thing can trick you into believing that it's actually doing something interesting, that it's looking around, or perhaps even by going down and looking blue, that it has feelings, or at least it can show sort of emotions. So the way that we perceive this whole field of robots has I guess, a great impact on whether, I guess, also these kind of inventions are really going to be successful. So,
yeah,
that, yes.
Yeah, for sure. And also, I would say the public, of course, on the one side, but then the end users of these systems. We are providing these to our customers, and we expect them to not only understand what it is supposed to do, but also to interact with it, to use it, and really trying to relay this message to them first, that, hey, this is not here to replace your job. This robot is not here to conduct the surgery for you. It is merely there as a tool. And I used earlier the perhaps stupid example of why would you try to fasten a bolt with your hands if you have a spanner lying next to you? And in the same context, if you have a robotic system that could just help you be better at your job, even though you're already, at the top point, then surely it should be seen as an assistant and not as a replacement.
Yep. I'm going to ask you later if this is the entrepreneur talking or the engineer. But first, let's. Is it everybody clear what Edwin has made?
Oh, this robot snake?
Yeah.
Well,
What
I
was
don't
it for?
think-
What was
okay.
it? What is
Oh
it?
yeah, that needs a little bit of explanation. You see some transparent pipes on the table. So right now in the Netherlands we have about 100,000 kilometers of gas distribution pipes, and unless we cut off the Russians and all the others completely, we still will be using gas for a while. And at some point we probably use the same network to distribute hydrogen. So there is this network. The only problem is we have no idea about the current state of this network. Currently, the gas distribution companies employ, I think, 15 million sensors distributed throughout the country to check on the status. You are these sensors, which means you are supposed to phone them if you smell gas. That's the only check they sort of do. They also have sniffer systems that they run across the street every 5 years, but that's it. So we had to devise a robot that could inspect these gas distribution mains on street level. So yes, the street that you're living at from the inside. So that's why it turns out to become a very complicated snake, which can take all kinds of bends and curves and diameter changes. And it's in fact a kind of Mars mission underground, because as soon as the robot is there underground, you lose all contact. I mean, it's not possible to have radio transmission underground. So it's really interesting, but also very complex problem. But yes, in order to convey the message, sometimes you have to use these tricks, and white lab coats
And
help
apparently it worked, also on you,
Mhm.
because you were inspired by it. But let's now go to your, what is it called, child?
We're still coming up with a name.
So
yeah.
this is an audience question. By the end, I'd like a few names for this.
Yeah, a few suggestions would be great.
Yeah, for this machine.
Yeah.
But how do you call it amongst each other?
Magneto comes to mind, but that's I think also one
I was thinking Flux 1.
The Flux one. Well, that's really
Because it's our first prototype.
Yeah.
And
I got it.
And so with each iteration, we will just move
But
up.
can we go? Can you
Yeah, for sure.
show
So-
us what we're looking at?
Yeah, okay, so of course the entire computer and computational system is also included in this card. But the idea is for this card to be mobile, so that you are able then to say, okay, we want to maneuver through operating theaters. We have a surgery in room 2A, where a patient has to receive a EVAR intervention, for example. And now, once you're done with that intervention, you say, okay, we cart the robot out of the way. The surgeon can continue with their operation, or move it entirely to another room. Now, inside this cover is an electromagnetic coil, and it's just function as a normal magnet. You know, if you want to put your pictures of visiting Sardinia on your fridge, you use a magnet for that. And in the exact same way, if you have a guide wire that the surgeon has to put inside your arteries, and this guide wire has a magnet on its tip, and you position this magnet on this side of the patient in order to deflect the guide wire, then you just turn on the electromagnet and it pulls the guide wire. So generally the clinician cannot have that functionality of a guide wire, because...
How would they normally do that?
Normally they make a cut on the leg, insert the guide wire, and then from this point, with their hands, try to feel through tactile feedback.
Really?
Okay, we are hitting now the edge, we go a bit left, we go a bit right, and they do this all from this distance.
And then they're pushing it upwards.
Pushing it in and pulling it out. And imagine you are all the way up here, you have to turn left, for example. How do you do that?
Turn it and squeeze it and from
left. So as you know, we approach clinicians first, and we ask them, listen, what problems are you facing in the operating theaters? And one example which I like to tell quite often, because it has had such a big impact on exactly how we designed this technology, was that the clinician told us they had to insert the guide wire to take to the renal artery, which is the artery that supplies blood to your kidney.
And before you go, does everyone know what a guide wire is? I don't know. Why is it used?
I believe that some might know, but just for sake of clarity, a guide wire is fundamental to every cardiovascular surgery. So it is exactly what it says. It's in Dutch is a voerdraad. This is a gewoon draad that you put into the vessel. And this wire has to be positioned to the target where they want to treat a disease. If they want to put a stent inside the artery, if they want to take a biopsy. And this guide wire is sort of the fundamental first stage of every intervention. What they do then, once the guide wire reaches that target,
for instance, the kidney, as you were just
for instance, the kidney. Then they put a catheter over it, which is yet another flexible tool that has then the stent, which they deploy, remove the guide wire, remove the catheter, and then the stent is there. And what the clinician told us is they had to do this intervention, and they struggled so much to deflect the guide wire into that artery that the surgery took 10 hours.
Really?
And a lot of blood loss, and the clinician got tired, and he looked at our proposal and he said, listen, if you can show me that this magnet could have just kept that guide wire there, because the guide wire was always just flicking out. They couldn't keep enough tension. And if you can show us that, by using this magnet, you can immediately deflect the guide wire, we put the stent in, surgery is done, that would save a lot of time. That would be beneficial for the patient. That would cause us to have, to complete this in 10% of the time it usually takes. So this is why we designed this coil to be positioned on this robot arm. Of course, if you introduce someone to the system, it is a bit scary, right? The clinician would look at it and say, whoa, how do I interact with this? So another priority of what we do at Flux Robotics is to ensure that the interface between the robot and the clinician is intuitive enough. Of course, we can use off-the-shelf components, such as the Xbox controller, which I believe everyone knows. And in that case, you do not need to understand what is going on inside the robot. You do not need to understand how the robot functions, what the inverse kinematics should be, what the forward kinematics are, all of those mumbo-jumbo. You just need to understand, okay, if it's intuitive enough for me to move around, and in fact, maybe you can try it out, or Edwin.
Yeah, let's
No, I already know how to operate robot. No. Yeah, of course. I never operated this robot.
There you go.
Okay.
First you try, and then we start with the real dummy.
Okay, so
show me.
I'm not going to tell you anything. It's just these two and these two.
Okay. Sure, and then let's give him a task, because I'll be the patient. I will sit here.
Yeah, you actually have to lie down, huh?
Yeah, but it's too low, yeah?
Your suit wouldn't allow that. So, yeah, you can just stand here. You sit here.
Yeah, I sit here.
You have a guide wire in your arm.
I do.
And we cannot push it past a certain point.
No, the muscle probably.
These two, or these two.
No. Yeah.
Down and up. Okay. It cannot do this rotation, can it?
Yeah, it can.
Oh, okay.
You have full 6 degrees of freedom.
Getting there.
Control.
Getting there. How safe is this?
That's the question, of course.
How patient aware is this robot?
Now you're asking. But please answer.
No, for sure. The certification behind the system is of utmost importance. If we want to allow the clinician to use it, and this approaches the patient in pretty much the same way you see here, we have to ensure that there's no risk whatsoever. Of course, without that insurance and certification, there's no chance for this system to be used inside theaters. Of course, the use of the magnet, I mean, there are
Is he doing okay?
Yeah, I think he's doing perfectly fine.
You have to hold the...
I think since, for sure you play a lot of Xbox back home, right?
Not at all.
But it's great to see that someone who doesn't even know about the system, you just provide them with a joystick, and they can use it themselves. Okay, let's assume that you have something in your brain that
you have something in your brain.
Yeah.
Oh dear.
Maybe you should sit a bit closer.
You sure?
There we go.
Oh.
You're also able to control with this joystick the orientation, huh? So not only the translation, but also orientation. Is it scaring you?
Well, I'm not sure what I'm scared of, whether it's the robot or the control skills.
It's also kind of a powerful feeling I have now.
This is why you should have anesthesia when this is being performed.
And which one does it shoot with?
No, the shooting function is the button.
Pressed A.
That is exactly the function that stops the robot. So.
Okay, well that worked. Thanks so much for this great presentation. Because I also could see you gliding there into your sales pitch of how the certification is really important.
I can't help myself.
But great. Yeah, is it all right like that? Or
yeah,
I want you to bump your head. What do you? Because you also make robots, but quite different ones. What do you get from this?
Well, what I really think is interesting that, of course, the controls they're really intuitive, and perhaps even a little bit because I know about okay, you expect something that can move in 3 dimensions and 3 rotations, so some mapping should be there. So I come sort of expecting something, but indeed, if it's really nice and smooth as it is, it feels like a tool. So that's a good thing. What I'm also curious is that at some point we were always really hesitant about deploying these kind of robot arms in public, because they have been around since the 1950s. You know, effectively the same company makes the robot arms that weld the cars together.
Yeah.
So that's what they're known for. So at some point we started deciding that if we keep them under control or something, they're safe enough to operate in the same conditions as we do, and that's really interesting, because of course I dived away a little bit, but yeah, you could easily force this magnet through my head, and there's probably no stopping it except you hitting the button A.
As I did.
As you did. So there's still that. So apparently we're sort of getting more comfortable with the idea that, yeah, well, there's a hammer, and of course you can hit your thumb with it. So there is some sort of shared responsibility. You cannot blame the hammer. We're always really finicky about robots, because robots are supposed to be these entities with their own brain, their own agenda, their own leitmotif. But as soon as this opinion sort of shifts, like, hang on, it's just a 6 degree of freedom magnet positioner. So no, it's not a robot, it's a 6 degree of freedom magnet positioner. Oh, that sounds a whole lot safer than a robot at my operation table.
Right.
So this perception, that's the thing that's
and this is something also because you're also making for movies and theater.
Yeah.
Robots. Is this also something you play with in that sense?
Yes, that's exactly the same thing that we're playing with if you're building robots for stage, or if you're building robots for movies. It's exactly this point that we cannot start building robots from scratch. So we cannot sort of step into this field naively thinking, oh, well, I've got a robot arm, and of course it can work well at your surgery table. No, as soon as you say something like surgical robots, then
they think the robot will do the surgery.
Exactly.
There was to interrupt, but in the Times magazine they said, would you trust your robot with a scalpel? And of course they want to make it sound as horrible as possibly as possible, because of course you would not trust a robot with a scalpel. I mean, they showed the Da Vinci peeling a grape. That's all nice, but what if this Da Vinci starts to peel your eyeball? You know, it's always the sense that the robot is in charge, and of course that's not the case.
At least not yet. And of course, we really want robots also to take more autonomous decisions, because the next step will be probably to program the trajectory that you want your guide wire to take, and then have this robot sort of follow is nice and automatically. I mean, you probably make an MRI scan of somebody, and you know the trajectory which it has to follow, and you say, okay, help me guide this wire now on autopilot. Yeah. And of course, we're going to build in more autonomy there, because that also has the promise of doing, or at least performing, better surgery in a way.
Right.
So yes, there is this tendency that we also want them as tools to be collaborative. Yeah, for sure. Really good tools. But right now, and where we are, it's still just a very nice 6 degree of freedom magnet holder. Yeah, and you still want the cognitive aspects of it, which of course can only come from our biggest benefit above robots, which is our brains. You still want the surgeon to be able to make decisions on short notice. If you have seen an operating theater, it's quite crazy. It's
it's an unpredictable environment. It's really no place for a robot that does his thing, pick and place, or make stitches in a repetitive fashion. It's really unpredictable, and artificial intelligence in that case is only meant for a predictable world.
Yeah, that's for sure.
But it's for sure a good long-term vision.
Well,
to try and reach.
I guess you see right now also in the operating room the sort of the influx from both sides. So it's one is the robotic tools, and the other side is of course also pattern recognition and data analysis, where you could, for instance, equip your robot arm not with a magnet holder, but with an ultrasonic scan sensor, and you make an automated scan of somebody's body, and then you have just data that you need to prepare your surgery, which can be much more accurate than you could obtain by normal means.
Yeah, for sure.
Then the analysis becomes automated. So yes, we're making steps in. Usually there's still the tools that assist the surgeons. And I guess that's a good thing, because you're absolutely right about the split-second decisions. That's something that our brains are wired up for, and artificial intelligence is not wired up for.
Yeah, you also stressed that in our talk beforehand, that it's to assist. Is that also something within the talks of the supposed users?
Oh, for sure. Yeah, we do get that question quite often, sort of hesitantly. Hey, is this going to replace my job one day? And we say, no, of course not. The point is that you provide us with input from your expertise, which is hard to get. You have to train at least 10 years to be there where you are now. The point is to know what you are struggling with, so that we can just provide you with that dark part which you are unable to solve. And so the clinicians that we show the system to, they even give us input. They say, oh, but why can't I just do this? Or why can't I just, why wouldn't you just allow me to do this myself while I insert the guide wire? And we really take that seriously, because eventually they have to choose to use our systems.
Yeah. And they need a sense of control.
Oh, for sure. The two things that any surgeon pride themselves with for conducting a surgery is their level of perception. So what they see is happening, being, let's say, awakened and really energized in that moment, and also their sense of control. Of course, inherently every human being would want to be in control. But during the surgery, if you suddenly tell them, okay, please go sit in that room. We also have 5G, so you can sit in a totally different country, and then you can do the surgery teleoperatively. Do they necessarily want to do that? I believe that they would still like to retain what they have been training and practiced for years and years on end, and paid a lot of money, not to just be told, okay, please control this robot and then do the surgery.
Yeah, well, it's going to be a generational thing, I guess, as well. Because, you touched already on the end user perspective. Well, I teased you a bit with going too close to you, but did you feel? Would you think it would be different if it would be for real if a doctor were doing it, or?
Yeah, I guess there's a fundamental difference if you know at some point that there is a human in charge or not. But it's the same like flying an aeroplane. I mean, usually you want their human body to be at the controls, or at least moderately awake. But everything from start to landing to just the flight is just on autopilot.
Right.
So we are sort of.
They just don't tell us that.
They don't tell us. So we're sort of.
Actually, they're telling us the opposite. They're saying,
this is your captain speaking.
Even that is a button that they press.
Good afternoon, this is your surgeon speaking. I'm fine dialing from remote through our wonderful 5G network.
Or even that is automated and say, this is your captain, John, speaking. But for sure, that is an interesting thing, and also how we as human beings react towards this. I was in and it's at a symposium where we drew a line in the middle of the floor, and we told the crowd, the audience, all right, please stand in the middle, and we would want you to either step to the left or right, depending on the following scenarios. If you have a disease that needs treatment, would you rather let a surgeon do it, that you know, person in the flesh, but with an 88% chance of recovery or success? Or would you let a robot operate on you with a 90%?
90%
And
88, yeah.
like one group, they all just went towards the surgeon, but even knowing, of course it was a very simplistic test, but even knowing that there's a higher chance of success, still is not convincing enough to choose a robot rather than a human being.
Whatever we do not want to be killed by robots.
No, I think everyone's seen too much Star Wars and Terminator, and you know the pop culture is not very friendly to us.
On the other hand, it could also help to our benefit, perhaps at some point. I'm also working in research towards social robots, and usually robots for care rather than cure. And one of the projects is also about developing helper robots for hospitals. I had a student model a couple of these robots in virtual reality, and he came up with a selection of all basically the same sort of robot figure. Looks a little bit like Pepper, but then with different color schemes. Everybody knows Pepper now, so a social robot in healthcare should be plastic Japanese Pepper robot, apparently. And for the fun of it, he also stuck a Dalek from Doctor Who. That's one of these exterminate robots with all the dubs. Yes, that's right. Okay, he stuck one of these robots. Sorry, that's your sci-fi pop culture.
Sorry, we're geeking out on you right now.
Yeah.
Sorry. Okay,
go ahead.
So yes, no, not going to explain it. Okay, so a robot from pop culture, that in between.
Yeah.
And of course, it was a joke, and he went, ha, ha, of course I will remove it. He thought he would remove it. But I said, no, hang on, stop. This is not how it works. Because if at some point I will be old, and I, for some reason, need to be in care, and need to be cared for by a robot, then I would so much more have like R2-D2 from Star Wars, or a Dalek, or whatever robot that I know treating me, rather than a little bit of anonymous white plastic programmed by whatever company.
Yeah.
I mean, this whole thing, what we expect and what we know by pop culture, and the thing that's sort of preventing us from accepting that we are going to be treated by robots, could also be sort of twisted around and be the bit that sort of helps us and accept the robot, or actually have a lot of fun with it. So that's also an interesting point. The two-sided sword of this whole. I mean, the whole field of robotics is being devised in theater. I mean, even the word robot comes from theater. It's a Czech word for slave labor, and the first play that had these robot slaves, Rossum's Universal Robots by Karl Čapek, a Czech playwright. So that was like robots come from theater, but also the whole narrative that they eventually will overthrow humanity and take over. And that whole narrative, the story, that's so built in. So that makes
something you're up against with health professionals.
And even if people hear AI, it's just the buzzword that they like to mention. What about AI? But even AI is just an umbrella term for a computer that can make decisions based on what you tell it, essentially. Yeah. So still there's a human operator providing the system with input, saying, okay, if you are playing chess, move knight to e5, also to make a Harry Potter reference, and then the computer can act on that. So it uses that data to make decisions. But it is not the case that suddenly it will, take the knight and decide, okay, I'm going to move. Entirely throw it out of the room or something, because
and I'm going to fold the new chessboard.
Yeah, and then I'm going to get up and start to exterminate people around me. That's definitely not the case. But of course, it's the first thing you think of if you hear AI, Terminator.
Yeah. Okay, I got a lot more questions for you, but I also want to give our lovely audience a chance to ask some questions. Is anyone who wants to ask a question? Yeah, you use this for the recording?
It will be blasphemy, but why the robot? Why not just holding the magnet in this case?
The surgeon holding the magnet for the guide wire.
No, I do appreciate that question. So essentially, if you consider that an intervention where these guide wires have to be positioned can be anything from 10 minutes to half an hour to an hour, 2 hours, this magnet weighs about 14 kilograms. For sure, some surgeons probably bulk up enough to be able to hold at a very steady position, this magnet, but it can be difficult on the long term if you need to hold a heavy object at one particular position that is preoperatively known to be in a specific angle and vector. That's what the robot is there for. So the robot is there to assist with the payload and also an accurate positioning, something that I doubt a human hand can do as well.
Thank you. Thank you for your question as well.
Can I get a follow-up question? If you look at this accurate positioning, so you do it with your Xbox controller, is the robot already able to do it by itself?
Yes, for sure it is. So originally, when we programmed the first prototype, so now before any mention of Flux Robotics was even there, we actually programmed multiple robotic arms to act autonomously. So a system was feeding it information on where these arms are located in the workspace through infrared trackers with optic track. It's the same motion capture systems they use in Xsense, and where they have to make computer graphic animations. And the robots acted autonomously, so we didn't have to do a thing. We press start, the robot brings the magnet, the catheter inserter inserts the catheter or the guide wire, and it deflects it wherever we program it to do. So for sure, that's already possible. However, if you want to introduce the system into the operating theater, you have to take a few steps back, start simple, have your minimum viable product ready for the clinicians, and then from that point on, work towards the same goal that we would want one day.
Thank you for this question. Someone else? Yeah? Well, you throw?
Yeah. So I have a question about the snake robot.
Yeah.
So is this already being used to inspect pipes in real life, or no? And what kind of challenges still need to be solved?
Actually, the challenge is much in line with what was explained here by Christoff. I mean, it's really down to the robot autonomy and how much autonomy you want to give to this robot. Right now, most robots in pipes are being controlled by operators from a distance, like these guys in vans suffering from tunnel vision, literally, because that's just what you're looking at. This robot that we came up with, it's also down to another problem that Christoff highlighted, the intuitiveness of an interface. I mean, the robot that we came up with has wheels and quite complicated shapes, so we ended up controlling this robot with panels and interfaces like these ones, which was fine for us because we got accustomed to these things. But so we became quite good robot operators, but really hard to train and transfer as a skill. Eventually, these robots for in-pipe inspection would be a situation where you really want your robot simply to autonomously go and do the thing, because at some point you will not be able to communicate anymore, so the robot has to be autonomous. And that's really still a tricky thing to develop, even in a structured or fairly structured environment like a gas grid, where you have, well, it is sort of predictable. Well, we thought it was sort of predictable, but then the real maintenance guy stepped into the project, started feeding us with information, as they usually do, and started complaining about beer lids, dead rabbits, and all the other things that they sometimes encounter in our gas grid, which are completely impossible to tackle by a robot or to train a robot for. So we're still in that stage where we really are training our robots, so neural networks, artificial intelligence, neural networks are being trained to cope with all these complex bends and stuff. But that's a lot of work. That's really in there for the long haul.
Yeah. AI.
Yes, that stuff.
Thank you for your question. Any other questions?
But it's so sorry, but this is really interesting because at the same time you explain we don't want AI, we want the operator to be in control, and for some cases we have to have AI because otherwise the solution is useless. So it's really an interesting balance again.
Yeah.
Context again.
Yeah.
Yeah.
In the back.
Hi. Another follow-up question to what he asked regarding the snake robot. So a lot has been being talked about, like how these robots approach these gas grids. What do you use to sense these kind of leaks and other kind of the damages? I'm asking this question because I'm aware of some UK-based company called Pipebots,
Yes, I know.
which uses ultrasound for the same purpose.
Yeah. So the problem with ultrasound at some cases is that you need a coupling medium, coupling liquid, and especially in a gas grid you don't want liquid, so we had to find other things. Visual inspection is still one. We used laser interferometry and other optical sensors to make a very good inside view, which can be used for navigation, but also for checking for cracks and those kind of things. And we also found a very simple one, sound. Just the sound of gas leaking away. So that's also in this prototype.
Thank you.
Thank you so much for your question. And we got time for one more.
Whole different question for Edwin about design of robots.
Yes.
You're referring to the pop culture and the way robots look alike.
Yeah.
What do you think about the future of these robots, especially in the care sector? Are they going to be more human-like?
Okay.
Not?
Quick test. Let me show you one. It was sort of tried to prepare it. Okay, this one. Who's the robot and who's not? You can immediately tell, can you? Yes, of course, the middle one. Why can't you tell? Why can you tell? A couple of reasons, probably.
It's kind of scary.
Still scary. All three of them.
It's scary, the feet. Of course, it's scary, so it's a robot. No, but usually you can tell by the little details. I mean, the closer we get to reality, the closer we get to something that's approaching the human looks, the closer we get to, okay, hang on, the eyes are not completely correct, or the more the details sort of stand out. So I personally think that this will definitely be not the way that we will go into for robots that we're going to use in care. And personally, I would enjoy much more a desk light nudging me to take a sip of water or remind me of taking my medicine, rather than the full-blown humanoid with all the realistic skin and other scary bits. So yes.
This is the answer is hidden in the future, I'd say, because really that's all we have time for. I think a great talk. Thank you so much, Jens. Really, what the Dutch Innovation Days are all about: to combine art and technology and entrepreneurship, and to see these great solutions and have a peek into the future. So I'd love to have a big hand for Christoff Heunis and Edwin Dertien.
Yeah, thank you.
Thanks.
Yeah.
Thanks a lot.
Thank you guys. Thank you.
Thank you.